let's now look at hypothesis test when we're testing a single proportion. Our first step will be to state the hypothesis. In this case, we'll have p equal to some number p0 that's given into the problem for our null hypothesis. And our alternative hypothesis will be either greater than, less than, or not equal to, depending on the situation in the problem. Next up will be our test statistic in calculating this. This is given by p hat minus p0 divided by the square root of p0 times 1 minus p0 over n. p0 is given by our hypothesis, p hat is our sample proportion, and n is our sample size. Next up is calculating our p-value. If it's a less than test, we'll use p norm of z. A right-tailed test or a greater than, we'll use 1 minus p norm of z. And if it's not equal to, 2 times p norm of the negative of z. If it was already negative, we'll leave it negative, and if it's positive, we'll make it negative. Finally, we make a decision. In this case, if our p-value is less than the given alpha, then we say h0 is false. A researcher claims that less than 40% of people get 8 hours or more of sleep per night. A study of 200 people showed that 76 got 8 hours or more of sleep per night. And we want to test the claim at a 0.05 level of significance. The first step is to state our hypotheses. And that's going to be what the researcher claimed. They're claiming less than 40% of people. This gives a null hypothesis of p equal to 0.4 or 40%, and an alternative of less than 0.4, since we're claiming that it's less than 40%. Next, let's look at our test value. Our formula for this, p hat minus p0 over the square root of p0, 1 minus p0 over n. So we really need 3 values. We need p hat. In that case, we have 76 out of 200. Dividing this shows us that p hat is 0.38. N is then 200, and our p0 is the 0.4 from our null hypothesis. Plugging these values in, and then calculating gives us our test value of negative 0.58. Next, we need to do our p-value. Since this is a less than test, we'll use the p-norm command of negative 0.58, and plugging that into R gives us our p-value of 0.28. Finally, we need to make our decision. For this, we need to compare our p-value of 0.28 with our level of significance, which is 0.05. And in this case, we can see that the p-value is actually greater than. Since the p-value is the larger of the two, that means there's not enough evidence to say that it is below 40%.